Welcome to part 2. We're on the 5th ACT prep lesson. Right now we're looking at page 569, and we're going to be moving into the passage on page 570 and answering the question that follows. As you do, recall the strategic thinking strategies. Actively read the passage, make sure we're noting the purpose and the hypothesis or key components, like the variables. Look for differences among the experiments, and identify any relationships if possible. One example that they're giving you would be cause and effect. Step 2, make sure that you examine or think about the figures that they give you. You're going to be given a couple tables here. A table 1, you're looking at variables, looking at collision rating on what is known as the Torino scale, as well as collision strength. And in figure 1, you're looking at 2 independent variables. The first independent variable, size of an asteroid, which is measured in 100,000 kilograms. And the second independent variable is humidity. In experiment 1, the bottom curve is measured at 86% humidity. That is an important characteristic to note. And in experiment 2, the top curve is measured at 12% humidity. Those differences, 86% and 12%, are going to be not directly seen in the data table or graph, but you'll need to know that information to answer the questions. So sometimes the questions do not give you, or the figures do not give you all the information you need. You do need to interpret from the reading. What we're looking for is the size of the asteroid increasing, the collision rating increasing as well with it. So a trend. If this happens, then this happens. Cause and effect. Passage 1. Please take a few moments, read through passage 1, and on your own, answer questions 1, 2, and 3. Once you've gotten through 1, 2, and 3, press play on the video again. I'm going to explain those, and then we'll look at the next passage. Alright, if you're listening to this video at this point, you should have taken the time to answer those first 3 questions. So here we go, looking through them. So question 1 is asking about the asteroid that killed the dinosaurs, and if it rated 9 on the Torino scale, and if the Earth's atmospheric moisture level at that time was approximately 86%, then how large was the asteroid that impacted Earth according to the research that was given? So we're looking at the curve that is 86%, which that actually gave us that information right up in here. The bottom curve was 86% humidity, meaning we are looking at experiment 1, the bottom of the 2 curves. So looking at this, I can go up to the value of 9, go over to this point right here, and then come straight down, giving me a value of 7, but keep in mind this is measured in 100,000 kilograms, so I'd be looking at 700,000 kilograms, making my answer C, which happens to be the correct answer. Looking at question number 2. In an additional simulation of an asteroid to Earth collision, a 400,000 kilogram asteroid received a collision rating of 4. The amount of moisture in the atmosphere was most likely closest to. Okay, so let's go back to our graph. Let's look for a 400,000 kilogram asteroid, which is right here, 400,000 kilogram asteroid. We were looking at it having a collision rating of 4. So if I go from 400,000 and I go up here and I take 4 and I come across here, it looks like it would be experiment 1, and recall, based on the information that was provided, had an 86% humidity, making our letter H the correct answer, 86% humidity. Third question tied to this passage: what would be the result according to the Torino scale of a 500,000 kilogram asteroid colliding with Earth at an atmospheric moisture level of 12? When we look at our answer options, we are given words in terms of what are the results, and we see that using the collision rating on the Torino scale over here. So to get this, we need to find an asteroid size of 500,000, which is right here. And we have to drag this up until we hit that 12% line, which looks like it does so right around in here. And when we slide that over, it gives us a collision rating of 7. So take this value of 7, look at it over here, 7. Looks like it would be a collision capable of a global catastrophe. So let's find our answer. Looks like D is our answer, a collision capable of a global catastrophe. Next section of questions, we're going to be evaluating experimental design, which you are guaranteed to see, asking you to identify the similarities and differences among experiments on the ACT. You will see this. Some of the more difficult ones are where you have to evaluate the design of experiments, meaning you need to think like a scientist and really understand that scientific method and understand why the experiments were conducted in the way that they were. So you do need to know the parts of the scientific method to really nail these questions. Recall that experimental conditions in them, we only really have one variable that is being changed. We also need to look at when that independent variable changes, does that cause anything to change with the dependent variable? So we're looking for cause and effect. Moving forward, we're going to skip up to the strategic thinking, which once again, same as what we've been looking at, actively read the passage and examine the figures. Read through passage 2, which begins on page 574, and answer the questions that follow. We'll be answering questions 4, 5, 6, and 7. Please pause this video, read through this, answer the questions, and then after you've had a chance to answer, press play again where you'll hear the explanation of how I got the answers that I got. Looking at question 4, it's asking which of the following factors did the researchers intentionally vary? So we have to be thinking, what did they change and what did they measure? So if we look at our provided data, both in table 1 and table 2, we have to think about what are they changing and what are they measuring. Based on both table 1 and 2, they are definitely measuring how much oxygen is being absorbed per hour in the skin and lungs and how much CO2 is being eliminated each hour in the skin and lungs. Now, what are they changing to measure these values? They are changing temperature in both cases. They're going from 5 degrees Celsius upwards of 25 degrees Celsius, meaning that H would be our correct answer. They are changing the temperature of that habitat. Question number 5 is saying experiment 1 and experiment 2 differed in that experiment 2. So it's asking, how is experiment 2 different from experiment 1? So let's go over here, let's look at our data. We see experiment 2 has table 2, experiment 1 has table 1. So what makes this one different from this one? Temperature is the same. They're measuring CO2 from the skin and CO2 from the lungs. Here they're measuring oxygen absorbed. So it looks like the difference is in what is being measured, the amount of CO2 eliminated in experiment 2. So let's find our answer. And it looks like they are measuring the carbon dioxide that is eliminated, which is exactly what we see here. So D is the correct answer. Question number 6. Which of the following best explains why researchers allowed the temperature in the simulated habitat to achieve equilibrium? Why are they allowing the temperature to become balanced before each temperature change? So it looks like they're not just allowing the temperature to go 5, 6, 7, 8, 9, 10, 11. They're allowing the temperature to go up to 5 and then they hold it. They're allowing the temperature to go up to 10 and then they hold it. Why would they do that? Well, the description over here is actually pretty good, but in my mind, what am I thinking? I'm thinking if I am told right here that they're bringing the temperature up and then holding it, are they doing that to remove oxygen from the habitat? Doesn't make sense to do that. Or to increase or decrease carbon dioxide levels. They would do that for G to allow frogs to adjust. Once frogs adjust to that temperature and they're in there for 5, 10, 15 minutes, now we can see how those frogs will actually react to that stable temperature of 10 degrees consistent, and we're not measuring how the frogs adjust as the temperature is increasing and increasing and increasing. So we hold it for frogs to adjust, and then we can get readings based on that temperature, not an increasing, consistent, constant temperature, making our answer G. Last question, number 7. Which of the following best explains why the frogs were placed in a controlled atmosphere designed to simulate their native habitat? So here is my thought process as I read through question 7 here. We're putting them in a controlled atmosphere. That means that we can control some things about that atmosphere. And we want the frogs to kind of be comfortable and behave as they would in their normal habitat. So we do want to try to make this atmosphere mimic where they actually live, and maybe even get the frogs tricked into thinking they're at their home place so that they behave naturally and other bodily processes aren't changed. So we have to keep in mind, what are we actually measuring? And we're measuring how much CO2 is eliminated per hour, or how much oxygen is absorbed per hour at the varying levels of temperature. Now we are changing the temperature, meaning we need to have a controlled atmosphere that we can, like the passage suggests, we have to be able to control it. So, reading through our answers, that really leaves us with option A as our answer. We want to control that temperature, but we want to leave the frog thinking that it's where it normally occurs. Now, excluding predators, well, that might be relevant and seem like an important detail for the survival of frogs in this investigation. We're not measuring predators, we're measuring how much oxygen these frogs take in or how much CO2 they eliminate. That would not really fit in with what they're investigating. Food supply, once again, that is kind of right by saying food supply, that's enveloped in their natural habitat. They're going to give them a food supply. And lastly, the researchers wanting to control the frogs' oxygen intake, that doesn't even correlate well with what they're saying. They're not trying to control how much they take in, they're trying to measure how much they take in naturally. A would be our best answer for question 7. This concludes this particular lesson. If you have any questions, please make sure that you reach out to me so I can give any clarification that you might have.